Okay, folks, today we're going to be graphing linear inequalities. Setting those boundary lines needs to be done correctly. Let's see what that's about. Here are some examples. The first two have greater than or equal to. The last one there is y is less than or equal to 5. Got to remember what those symbols mean. And on the right-hand side, we have less than on the top example and greater than on the next example. Why did I separate them? Because to help you remember your boundary lines. If it's greater than or equal to or less than or equal to, you need a solid line. If it's just less than or greater than, the line you create needs to be a dashed line. So here's my first example. In this one, I'm going to be showing you one way of doing this. You could change it to y equals mx plus b format. I take away the 2x, I multiply by -1, and here's another rule to remember, that whenever you multiply or divide by a negative number, you need to change and switch the inequalities. So it becomes y is greater than 2x minus 6. Just like y equals mx plus b, the slope is in front of the x, which is 2 over 1, and the y-intercept here is -6. So I plotted the y-intercept, and I went up 2 over 1 and up 2 over 1. It is a positive slope, creating a line. Now, should it stay solid? Look back at the inequality. It does not contain equal to, so we are going to dash that line. And I'm going to test a point on one side of the line or the other. You can choose any point you want. I often choose 0, 0. If the line does not go through 0, 0, then you can choose that point, and it makes the math easy. Plug in x 0 and y as 0. There is the equation. Is 0 going to be greater than 2 times 0 minus 6? That's the new question. And 0 is greater than -6. That means that every point on the left side of the purple line will be a solution. This is called the solution set. Example number 2. It's 3x is greater than or equal to y. So let's graph the line. This time I'm just going to plug in some points. So what if x is 0? Well, 3 times 0 is 0. So that means that when x is 0, y is 0. Now another point, when x is 1. Well, 3 times 1 is greater than or equal to y. That means when x is 1, y is 3. Making my little graph. I'm plotting the points 0, 0, 1, 3. I draw my line. Does it stay solid or does it become a dashed line? Hopefully you're saying it stays solid, and when you would be right. But we can't use 0, 0 to test this time, so I'm going to pick another point. And this time I'm choosing 4, 0. I put a little purple line on it to see what I'm choosing. It's on the right side of that line. Plug in the 4 and the 0. We get 12 is greater or equal to 0. And that's true. That means that every point on the right side will also be true. We don't have to test them all, thank God. Alright, what about something simple like this? I know you guys forget, so this one I chose x is less than 2. You draw a horizontal line wherever x is 2. Sorry, a vertical line wherever x is 2. It is going to be dashed because that does not have an equal to part of it. The question is choose an x. So I'm choosing, I've already told you, I'm always going to choose 0 if I can. Is 0 less than 2? Well, sure is. So I shade everything to the left of the dashed line. Another example. All right, again, I changed this one to y equals mx plus b format because I think most of you are more familiar with that. By moving the 2x from the left over to the right. Remember, when you cross over the equal sign, you're actually taking away the opposite of the other side. So now we have y is less than or equal to negative 2x plus 1. The y-intercept would be 1. And we go down 2 and over 1, making a negative sloped line when I draw through. We have to choose a point. What do you think I'm going to choose? Oh, maybe 0, 0. Okay. So I'm plugging in 0 for x and 0 for y. And there it is, plugged in. Do the simple math there. 0 is going to be less than or equal to 0 plus 1. Because negative 2 times 0 is 0. Is that true? Yes, it is. Which means everything on the same side as 0, 0 would be shaded and be a part of the solution set. Our last example for this is 2x plus 4y is greater than or equal to 8. And again, this time I'm just going to plug in methods. I don't know if you remember it, I called it the cover-up method because basically I'm choosing to make x 0 first. 2 times 0 is now 0. So the equation I'm left with is 4y is greater or equal to 8. Divide by 4. That means that y is greater or equal to 2. Now I'm going to make y equal to 0. Again, think about it. 4 times 0 is 0. Now my new equation is 2x is greater than or equal to 8. I divide by 2. X has to be greater or equal to 4. That's my second point. All I need is 2 to graph a line. And so we're going to plot 0, 2, which is the y-intercept, and 4, 0, which is the x-intercept. Draw my line. Now, should it stay solid or should I dash it? Well, it should be solid because there is an equal to. It's greater than or equal to. Okay, so I'm going to plug in 0, 0 into the original equation. So is 2 times 0 plus 4 times 0 greater than or equal to 0? Hopefully more of you are saying, no way, because 0 plus 0 is certainly not greater than or equal to 0. So that gets a red X. It's a no. So then where do I shade? Shade everything on the opposite side of the line, above the line, or to the right of the line, however you look at it. So that would be it for today. Stay strong, stay positive out there, and I hope you guys have an awesome week. Thank you so much for watching. You're my math hero if you made it to the end of this. Have a great week, guys. Bye.